Hello everyone. In today's session, what we'll be trying to do is we'll be solving some problems based on Nernst equation. Okay. So we'll be trying to take different types of problem. Okay. Which we get in Nernst equation in board examination or in various entrance examinations also. So we'll try to take them, try to understand how to solve it, how to tackle such problem, and how to get the answers. Okay. So let us start with the very first problem. Okay. Calculate the EMF and delta G, that is the Gibbs free energy, for the following cell at 298 Kelvin. Okay. So we have to calculate EMF and delta G for the following cell at 298 Kelvin. They have given us the cell representation, which you can clearly see. Okay. So this is the cell representation. And they have given the electrode potential of magnesium and that of the copper. Okay, so these two things are given to us. So how to tackle such problem in examination? Now, first thing, in examination, they will not be telling you to use Nernst equation. So how do you know that you have to use Nernst equation? Because EMF, we can get it by two ways. Either I can use the formula E cathode minus E anode, that is the standard EMF, and the other EMF is at other condition other than the standard cases. Now over here, how do I know that I have to use Nernst equation is from this given value of concentration. Can you see the ions Mg2 plus and copper is given a value which is not 1 molar. If these values are 1 molar, what we need to calculate is the standard EMF, that is E cathode minus E anode. Okay. But if it happens that they have given us this type of concentration, which you can easily see, which is not actually the standard condition. So in such cases, what we have to do is we have to use Nernst equation. So that is how I know that I have to use Nernst equation. Most of the student goes wrong in such type of problem by using the other formula for calculating the standard EMF. So in this particular problem, when they are telling you to calculate EMF, they are not telling you to calculate the standard EMF. How do you know that? Because the concentration is not 1 molar. Okay, so you have to use Nernst equation. So that is what actually Nernst equation is all about, to calculate the EMF of a cell which is not at its standard condition. Now, so this what is given to you is the standard case. Now the question is, what is the chemical reaction going on? So first what we'll try to understand is from a cell representation. So this is what is given as a cell representation. From this cell representation, how to write the chemical reaction. Okay, so that is what we will be trying to understand first. Okay, so any cell representation, whenever they give you, okay, remember that left, this one, okay, is your anode and right is your cathode. That means magnesium is your anode and copper is your cathode. Okay, magnesium ion is the electrolyte in anodic bath and copper is the electrolyte, or copper ion is the electrolyte in the cathodic bath, okay, with the particular concentration. So how to write the reaction? So whenever they tell you to write the reaction, or in such cases you need to do that, so what we'll do first is we'll write the reaction. So the simple way of writing the reaction is Mg goes to Mg2 plus. So that is how we'll start. So magnesium, okay, goes to Mg2 plus. Now how? Magnesium, if it is going to Mg2 plus, how it can? Obviously by losing 2 electron. So that is happening in your anode. Okay, left hand side, always anode. Okay, so it is losing 2 electron, it is losing. So it is oxidation. Then copper, Cu2 plus, is going to copper solid. So Cu2 plus, okay, is going to Cu. How? by taking how many electrons? Cu2 plus to Cu now. So it has to take 2 electrons. So magnesium is going to Mg2 plus, Mg is going to Mg2 plus, Cu2 plus is going to Cu. So once we are done with that, then you just add this two reaction. This is oxidation, loss of electron. This is reduction, gain of electron. So oxidation and reduction, if I'll add it, what I get is a redox reaction. So you add this two, the number of electron is same, so they get cancelled out. So what I'll get is Mg, which is a solid, reacts with, so you add right hand side, left hand side plus left hand side. So what you have is Cu2 plus. What is the concentration of Cu2 plus given? 10 to the power minus 4 molar gives you. So what it will give you? It will give you Mg2 plus. Okay. What is the concentration of Mg2 plus? 10 to the power minus 3, sorry. 10 to the power minus 3 molar plus copper, which is a solid. Okay, so we got our reaction, right? Now what we'll try to do is, first we'll try to find out, or what is our working formula. So we need to find E cell. So what is Nernst's equation for a cell? So E cell will be equal to, so what was the formula? E naught cell minus, now if it is standard temperature 298, the formula is 0.0591 by N log of product by that of reactant. Always remember that. Okay, so that's why writing the formula becomes, actually if you write the chemical reaction of a particular cell, then it becomes very easy to work with. Always remember that product by that of reactant, and the concentration of solid is always taken to be unity. Okay, 1. So we have to take the concentration of the ions only. So concentration of product is Mg2 plus by concentration of the reactant, that is Cu2 plus. So now what we need to do is just put the values. So what is the value of N? N is the number of electron involved. So how many number of electron is involved? 2. So therefore N will be equal to 2. Okay. Now the next thing is E naught cell. What is E naught cell? E naught, standard EMF. So how to find E naught cell? So E naught cell will be equal to E cathode minus E anode. What is your cathode? E cathode. Now which one is your cathode? Always remember that if you want to find out from the reduction potential value, higher the reduction potential, always act as cathode, lower the reduction potential, always act as anode. So this is higher. Okay, so if this value is higher, this is acting as cathode. Or from the chemical reaction, if you want to find out, always anode means oxidation, cathode means reduction. So copper is undergoing reduction, so copper is cathode. Magnesium is undergoing loss of electron, that is oxidation, so magnesium is anode. So that is how you can find. So cathode having a higher value, that is 0.34 minus of minus 2.36, which if I will add, because minus and minus becomes plus, so 0.34 plus 2.36 will give me 2.70 volts. So E naught cell we have, and we have. So let us just put the value. So this implies E cell will be equal to, E naught cell is 2.70 minus 0.0591 by N log of, what is the value of Mg2 plus? Mg2 plus is 10 to the power minus 3, and copper is 10 to the power minus 4. Okay. Now, if I just calculate this value, okay, n value also we can put, instead of n, we can write that will be 2. Okay, so now what we can do is just simplification. Okay, that is 2.70. Now 0.0591 by 2 will give you 0.0295 log of, now 10 to the power minus 3. When 10 to the power minus 4 goes into the numerator, it becomes 10 to the power 4. So 10 to the power minus 3 into 10 to the power 4 will give you log 10. Now, I hope everyone knows the value of log 10. Log 10 is 1. So if log 10 is 1, what will be left is 2.70 minus 0.0295. Log 10 value is equal to 1, which will give you a value of 2. If you deduct it, it will give you 67. Okay, so it will be 2.6705 volts. So that is your answer. Okay, so for the calculation of EMF. So the next thing which they have told us to calculate is delta G. Now let me just do it here. So what is delta G? Delta G naught is equal to minus NF E naught cell. That is the relationship between EMF and Gibbs free energy. Now it is just about putting the value. Minus N is 2, F is 96,500. It is 1 Faraday. And E naught cell, we know that is 2.70. Okay, so if that is the case, then if you just multiply this, whatever the value which you get is your answer. Okay, so that is how we calculate the value. So the value which you'll be getting is minus 515,310 joule, which you can convert to kilojoule by dividing by 1000. So it will be minus 515.31 kilojoules. Okay, so that is how we solve such kind of problem. So the important thing is to write the chemical equation, okay, as I have actually shown you. Okay, so that is how we solve the problem for Nernst equation. Okay, how to calculate EMF and delta G naught. Okay, so let us try to go for the next problem. So let me just clear this. So our next problem is, so it is based on equilibrium constant now. Okay, so calculate the equilibrium constant for the reaction. Okay, so we have to calculate the equilibrium constant for the reaction now at 298 Kelvin. Okay, and the reaction which is given is zinc plus Cu2 plus gives you Zn2 plus Cu, and given is the electrode potential of zinc and the electrode potential of copper. Okay, so what we have to do now is to calculate the equilibrium constant. So first, let us try to write the formula for the relationship between equilibrium constant and the cell potential. Okay, so if I go with the working formula, so the formula is E naught cell will be equal to 0.0591 by N log of K or Kc, depending upon which notation you use. So that is the formula. So what do we require is K. We want to calculate this K. N value, I hope everyone can make it out. Zinc is going to Zn2 plus. So if you are confused over here, you can write the half reaction. So zinc is going to Zn2 plus. How many electron it will give? Obviously 2 electron. Okay, I hope everyone can understand that. Then Cu2 plus will take 2 electrons. Cu2 plus will go to Cu. How? Obviously by taking 2 electron. So how many electron is involved? You can see the value of N. So therefore N is equal to 2. Okay, so that is what we want to find. So now first we need to find E naught cell. So how to find E naught cell? E naught cell will be equal to E cathode minus E anode. What is E cathode? Now always I have told you the one which get oxidized or oxidation is taking place, that is anode. The reduction where taking place, it is cathode. Or higher the reduction potential value, that is cathode. Lower the reduction potential value, that is anode. So higher reduction potential is for copper, so that is cathode. In another way, copper is undergoing reduction, so it is cathode. Okay, so copper is my cathode, so it is 0.34 minus of minus 0.76. So it will be 0.34 plus 0.76. Okay, so that will be 1.10 volt. Okay, so that is our E naught. So let us just put the value now. So therefore, so 1.10 will be equal to 0.0591 by N value is 2 log of K, which I don't know. So to find out log of K, what I need to do now is log of K will be equal to 1.10 cross multiplication into 2 by 0.0591. Okay, so if I will calculate that, okay, the value which I will be getting for this particular simplification is 37.2250. Okay, then we don't want log K, we want K. So I hope everyone knows this. If you don't know, so what we have to do is K will be equal to anti-log of the value, that is 37.2250, which will come out to be 1.679 into 10 to the power 37. Okay, so that is how we calculate the problem based on equilibrium constant and the cell potential. Okay, so let us move into the next. So our next problem is again based on EMF. Okay, so which is nothing but calculate the EMF of the following cell. Okay, so we have to calculate the EMF of the following cell. So who's at 25 degrees Celsius, and the cell which is given is again a cell representation where silver is acting as our anode and the copper is acting as our cathode. Now the question is how to solve that problem. Again, it is very much similar to our first problem where we have done the EMF and delta G. So over here, it is just the EMF. Okay, so how to solve such problem? So first thing what we need to do, again in the very similar way, we have to write the chemical equation. Okay, so what is the chemical equation? Again, very similar. Ag is going to Ag plus, Cu2 plus is going to Cu. Okay, so that is how you have to start. So the reaction which is taking place is Ag is going to Ag plus. So how many electron it is losing? 1 electron. Cu2 plus is taking how many electron? Obviously 2 electron to give you Cu. Okay. So Cu2 plus, obviously it has to go to Cu, so it will take 2 electrons. So if you want to now sum it up, you can clearly see Ag is giving you 1 electron, but Cu is taking 2 electrons. To equalize it, I need to multiply the above equation by 2 because I need 2 electrons for copper, right? So what I'll get is, now I have to multiply the whole thing by 2. So if I take 2 electron and 2 electron, right hand side and left hand side cancels out. So what is left is 2 Ag, okay, multiply by 2, solid, plus Cu2 plus copper, and the value is 10 to the power minus 1 molar, gives you what it is giving you. It is giving you Ag plus how many? 2. So it is giving you 2 Ag plus, okay, and plus what is the value of the concentration? It is 10 to the power minus 3 molar, and plus obviously copper, which is a solid. So that is our cell reaction. Okay, so once we get that cell reaction, now it is just about putting the value in our Nernst equation. Now why do we have to use Nernst equation again? Because the value of the concentration which is given is not 1 molar, it is not in standard conditions. So E cell will be equal to E naught cell minus, again the temperature is 25, 298, so it will be 0.0591 by N log of, again I am telling you, product by that of reactant. Now what is our product? Copper and silver ion, but copper is a solid, so I will not take copper. Copper value will be unity. Silver ion will be Ag plus. Now always remember that if there is any stoichiometric coefficient, in simple word, number of moles, like 2 over here, you have to always raise it to the power. Okay, don't forget that. Most of the students make mistake in this. Okay, that's why balancing and writing the chemical equation is very important. From here you will never be able to know that there will be 2. Okay, so that part you always remember. By copper Cu2 plus, okay. So since there is no number of moles, you can clearly see I'm not writing, and Ag is a solid, concentration will be taken as 1. So now we need to get E naught cell. So how to get E naught cell? Let me do it here. E naught cell will be equal to E cathode minus E anode. So what is the value of cathode? The value of cathode, now which one is cathode? Okay, we need not calculate E cathode minus E anode because they have clearly given us the value only, right? So, okay, we can put the value. E naught cell is directly given to be plus 0.46 volt. So we need not calculate. Okay, so it is directly given in the question itself. So 0.64. So let us just put the value. So therefore, E cell will be equal to E naught cell is 0.46 minus 0.0591. What is the value of N? N is 2 electron transfer. Okay, remember that. So 2 log of Ag plus. What is the value of Ag plus? 10 to the power minus 3. And don't forget it is raised to the power 2. Okay, and copper is 10 to the power minus 1. Okay, so now it's just about simplification. So if I do this, what I'll get is 0.46 minus 0.0591 by 2 log of 10 to the power minus 3 and to the power 2, 10 to the power minus 6 by 10 to the power minus 1. Is it not? So now what I'll get is, if this goes to numerator, it becomes 10, 10 and 10 to the power 1 and 10 to the power minus 6. I'll get 10 to the power minus 5. So it will be 0.046 minus 0.0591 by 2 log of 10 to the power minus 5. Okay, so now I hope you understand log of 10 to the power minus 5. If you don't know, log of a to the power m is always equal to m log a. that is logarithm, right? So if I put that value, what I'll get is it will be equal to 0.46, not 0.046. It will be just a second. If it will be 0.46, okay, so 0.46 minus 0.0591 by 2 into 10 to the power minus 5 will be minus 5 log 10. Log 10 will be 1, so it will be multiplied by minus 5. So if you simplify all this, the value which you will be getting is the value which you will be getting is 0.3123 volts. Okay, so that will be your proper answer. Okay, so that is how actually we solve it. Okay, sorry, I think I have made a mistake over there. It cannot be that, okay, because you are not deducting it, because you will be adding it. So you will not get 0.046. So if we calculate that, so what we'll be getting is, so it will be 0.46, okay, which is your value of the E cell. And if I'll deduct that value, what I'll get is, if I'll add that value, minus and minus becomes plus. Okay, over here, minus and minus becomes plus. So it will give me, so just a minute. So it will give me 0.60775 volts. Please cross check the answers. Okay. So that is how actually we solve such problems. Okay. Now let us move into the next problem, which we have. So our next problem is calculate the EMF of the cell again, okay, of the following cell, and again a cell representation is given. Okay, again very much a similar question. Okay, so let us just try to solve this again. So how to solve such problem again? First we need to write the chemical reaction. So what will be our chemical reaction for this particular reaction? So I hope now you can write it. Come on, start it. So what will be the chemical reaction? So the chemical reaction will be Fe will be going to Fe will be going to Fe2 plus 2 electron, is it not? Then H plus is going to H2. So H plus, obviously how? By taking electron, is going to H2. So since there are two hydrogens, so let me balance this 2. So 1 H plus will take 1 electron, 2 H plus will take 2 electron. So that is our oxidation and reduction. So once we are done with this, then what is our next job is to do is just add this particular reaction. So what I'll get is Fe solid, okay, which will be added with 2H plus, whose value is given to be 1 molar, okay, gives you Fe2 plus, whose value is given to be 0.001 molar, plus H2, obviously, which is a gas. Okay, again, what we need to do is use Nernst's equation. So E cell will be equal to E naught cell minus 0.0591 by N log of product by that of reactant. Product, we have to take ions, so it is Fe2 plus. Remember that the value of a pure solid, liquid or gas is always taken as unity. So H2 will be unity and Fe will be unity. So I have to take this H plus, which is also unity. So let me just take it for this case. So H plus, and obviously it is to the power 2. So raised to the power 2. Okay. So now just let us put the value. E naught cell value is given. Okay. The value of E naught cell is given to be minus 0.44 minus 0.0591 by n, and the value of n we know now. N value will be equal to 2. So the value of n is 2 log of, okay, Fe is 0.001 by, and the value of H which you will be solving is obviously 1 to the power 2. So that is 1 only. So what is left with us is 0.44 minus 0.0591 log of 0.001, which you'll get your answer. So kindly solve that. You'll get your answer for the problem. Okay. So that is how actually we solve the problem based on Nernst's equation. Okay. And over here, I think there is a mistake in the equation. The value has to be positive. Okay, there it cannot be negative value. So there is a mistake. E naught cell is 0.44. Okay, so don't take it a negative value. It cannot be negative. It is positive. Maybe a typing mistake in that. So it is plus 0.44. So it will be plus 0.44 value. Okay, so it will be this. So which, if you will solve it, the value or your answer which you'll be getting over here will be equal to 0.5 to 86 volt. Okay, so that is your answer. So that is how you solve the problem based on Nernst's equation. Okay, so this is how we solve. These are the different types of problem which you'll encounter in your board, which you'll encounter in your NEET examinations or JEE examinations. Okay, so that is how we need to solve. So the important thing, the most important thing is to convert a cell representation into reactions. Okay, how to write anode and cathode, and then finally go for the problem and solve it. Okay, so that's all for this particular session.